Hi grade 8. So what we've done so far is topics 1 to 3, which are probably the most difficult parts of equations. And all of those equations we've done so far were something called linear equations. Now they're called linear equations because they simply involved x or y or a, but basically they had nothing with an exponent. So there was no x squared, there was no y squared, there was no a squared. And so this topic 4, is just a little bit of a taster of what equations are going to come in grades 9, 10, 11 and 12. So they like to ask one or two of these questions in a grade 8 paper, and they are not meant to be difficult, they're just meant to be different. And so we're going to look at a couple and hopefully figure out a kind of method for each of them. There's no real hard and fast method in grade 8. They're just interesting questions which you can probably just think about and get the answer to. So it's not like linear where there's a set method that we follow. Now they will get more complicated and they will get methods, but only in the higher grades. So for now we keep them quite easy. So let's have a look at topic 4. It says solving equations with exponents. So example 1, it says solve for x, and it says x squared is 25. Now literally I would just expect you to think, what squared would give me 25? So not like a method like the linear equations. What squared would equal 25? And I'm hoping that you would say, hang on, well, if I squared 5, I'd get 25. Now, how do I know that? What happens if it's a big number that I can't, 25 is something that I'm quite familiar with. What happens if it's a big number? Well, to figure out what squared gives you 25, you can just square root 25, and you'll get 5. Now there's a catch here, because if you are squaring something to get 25, there's not only one answer, there's two. Now this is the first type of equation where you can get two answers for the same equation. If you think about it, when you square something and you get 25, yes, you could say 5 squared. Would you also not agree that you could square negative 5? So negative 5 squared, I'm actually not going to write those brackets. I'm going to rather put them here, and I'm going to say because, remember that's the symbol for because negative 5 squared, when you square a negative, you get a positive. Because a negative times a negative, this means negative 5 times negative 5, which is positive 25. So when you have something squared, don't forget that there's always two answers, because it can be positive or negative. So there's always two answers when you have something like x squared. And that's because it can be positive or negative, because when you square both of those, you get a positive. So that's quite a cool question. Again, that would be 2 marks, because there's no method. We just need to think about what we know about exponents. Okay, let's look at another one with an x squared. X squared equals negative 9. So again, I wouldn't really do a method. I would just say to myself, what squared gives me negative 9? Now, this is a bit of a trick question, because can you ever square something and get a negative? Because when you square something, you mean something times itself. So I'm tempted to say, well, 3 times 3, because 3 times 3 gives me 9. But you want negative 9. So if 1 is a negative, careful you're squaring it, so it has to be multiplied by itself. And what's a negative times a negative? A positive. Okay, so what happens if it's positive 3 times positive 3? Well, that's also positive 9. So there's no ways at all to be able to square something and get a negative. It's just not possible. Simply because you have to multiply something by itself. So you have to have the same signs in both the numbers. So you're always going to land up with a positive. So there is no solution for x. There's no value for x that makes this work. So we say no value for x, or we say no solution for x. Now, that was a bit of a trick question. I probably wouldn't put that in an exam. It was just to remind you that just be careful. Whenever you square something, you always get a positive. Okay, let's try another one. What about 2x cubed gives you 16? Well, basically, you are going to cube something, then you're going to multiply it by 2, and you want to get 16. So probably the easiest way to do this question is, why don't we try and get the x cubed alone? because then we can say what cubed gives you, and whatever the answer is. So we'd say what cubed equals, and we don't know what that is. So how do we get x cubed alone? Well, I need to get rid of multiplying by 2. So exactly like I did in the previous equations, I'm going to divide by 2 so that I can get x cubed by itself, and 16 divided by 2 is 8. So now I'm saying to myself, what cubed gives me 8? Now, I'm hoping that you can think about that. What times itself gives me 8. But if you don't know if it's a big number, do you agree you could cube root? Because the opposite of cubing is cube rooting. So if you don't know what cubed gives you 8, you can just cube root 8, and the answer is 2. Now I'm tempted to say, oh gosh, is it negative 2 as well? Because with the squaring, we said, oh gosh, no, it's not only positive, it's also negative. Now, why is this not also negative 2? So this only has one answer, and that's because if you have negative 2 times negative 2 times negative 2, the 2 times the 2 times the 2 absolutely gives you 8. But a negative times a negative is a positive, times a negative is a negative. So just notice that when this is actually called a cubic equation, if it's raised to the power of 3, there's only one answer. So it's only this power of 2 where the answer could be plus or minus, because when you square, the signs disappear. When you cube something, the signs don't disappear, because a negative times a negative times a negative remains a negative. Okay, let's try another one. Now this is interesting. What square rooted will give you 4? So you just have to say to yourself, what square rooted will give me 4? And again, I'm hoping that we could think about this. What would I have to square root to give me 4? And I would say, well, the answer is 16, because I know that the square root of 16 is 4. Now, what happens if you didn't know that? What happens if it was what square rooted gives you 15, and you don't know what square rooted gives you 15? Well, I could say 4 squared gives me 16. Therefore, when I square root it, I would go back to 4. So the square root of 16 gives me 4. So it's almost like when we did linear equations and we spoke about inverse operations, the opposite operations. So the opposite operation of squaring is square rooting, and the opposite operation of square rooting is squaring. So if you don't know what square rooted will give you 4, why don't you just square 4 so that you can see what square rooted would give you 4? Okay, let's try question E. Question E says x squared minus 1 gives you 63. Now that's great. I want to first get x squared by itself so that I can say to myself, what squared will give me something? So my first kind of step, if there is one here, is get x squared alone. So what I'm going to do here is I'm going to say I have x squared minus 1, and I don't want that minus 1. So I'm going to add 1 to both sides. Add 1, add 1. So that gives me x squared. Oh no, I don't know why I wrote 64, because I think I was doing it in my head. 63 plus 1 is 64. And now I'm going to say to myself, right, that's great. What squared gives me 64? Now again, hopefully, I say squared, so immediately I'm thinking, there's going to be a positive solution and a negative solution. So what squared gives me 64? Now you might know that. The answer is 8, which means the answer could also be negative 8, because negative 8 times negative 8, the negatives would cancel to a positive. Now, what happens if I didn't know what squared gives me 64? I could just say, okay, so what's the square root of 64? If I didn't actually know that, because then I'm actually asking what the square root of 64 is, because then I know what squared would go back to 64. So don't forget this idea of opposite operations. It's very, very helpful. Okay, question F. We've seen one of these before. I'm going to get my x cubed by itself, because then I can say to myself, what cubed gives me, and let's see what it's going to give me. So how do I get rid of adding 3? I'm going to subtract 3 on both sides. So I land up getting x cubed equals minus 27. And then I say to myself, what cubed equals negative 27? Okay, now if it's a negative, I'm pretty sure x is going to have to equal a negative, because a negative times a negative times a negative would have to give me the negative. If this x was going to be positive, then this would have to be positive 27. So I'm pretty sure x cubed is going to have to be negative. So then I say to myself, sorry, x has to be negative to make x cubed negative. So then I say to myself, okay, how do I get 27? Now once you've been doing this a long time, you know that 3 times 3 times 3 gives you 27. If you don't know that, you can just cube root negative 27 on your calculator, because that will tell you what would cube to give you negative 27. So it's almost using the same idea, it is actually using the same idea as inverse operations. Okay, let's look at another one. This is quite interesting. This says I am cube rooting x, then adding 1 and getting negative 3. Okay, so once again, I want to get this cube root of x by itself. Then I'm going to think about the question. So if I have the cube root of x plus 1, I'm going to want to subtract 1 to get that rid of that plus 1. So I'm going to subtract 1 on both sides, and then I get the cube root of something. The cube root of I don't know what is equal to negative 5. So the cube root of some number equals negative 5. So how do I figure out what x is? So negative 5 must be the cube root. So if I cube negative 5, I get negative 125, which means when I cube root negative 125, I'll go back to negative 5. So in order to figure out what must I cube root to get negative 5, I'm going to cube the negative 5 to figure out where it came from. So if I cube negative 5, I get negative 125. So that's the idea of opposite operations. If I'm trying to figure out what I must cube root, I'm going to cube the negative 5 to figure out what I originally cube rooted. I hope this kind of makes sense. It's exactly the same idea as inverse operations. So a square root is the inverse operation for squaring something, and a cube root is the inverse operation for cubing something. Now we don't use them so kind of officially in grade 8. We just want you to kind of think about it at this type of level. Okay, let's try one more tricky one. One more tricky one says the square root of 2x plus 4 equals 8. So I want to get this square root of 2x by itself. So the square root of 2x plus 4 equals 8. So you'll notice every single one of these is about getting that x mess by itself. So I'm going to subtract 4 on both sides, which gives me the square root of 2x equals 4. Okay, now there's multiple ways to do this. The first way is to think to yourself, well, what would I square root? What would I square root to get 4? And hopefully you know that. What would you need to square root in order to get 4? You would need to square root 16 to give you 4. So whatever's under the square root sign has to equal 16. This 2x has to equal 16, so that when you square root 16, you will get 4. Then I would divide by 2 on both sides, and I'd get x is equal to 8. Now let's go check. 2 times 8 is 16, and the square root of 16 is 4, and so it works out. So I like that type of method in grade 8. I think about it. What do I want to square root so that my answer is 4? I need to square root 16. So whatever's under that root sign needs to be equal to 16. Okay, another way to do it, so I'm going to say, or if you have the square root of 2x equals 4, you could say to yourself, okay, well, I want to undo the square root, so I'm going to square. So if I'm trying to figure out what am I square rooting to get 4, it must have come from 4 squared. So that when I square rooted, I went straight back to 4. So this thing under the root sign must be equal to the square of 4, so that when I square root it, I go back to 4. So 2x has to equal 16. Now, I find that method a little bit tricky for grade 8. I prefer this method where I just say to myself, what would I square root in order to get 4? Because that must be under the square root sign. So I think these equations are not difficult, but they're tricky in that there's no like one method like the linear equations. So they're a little bit interesting and they require you to think a bit. So the only real method we've come up with is try and get the x mess by itself and then think about what the question is asking you.